Cache Memory by Division A, Group 4.
Hello everyone, we are group 4 and our topics for today's presentation is cache memory. Here are our group members. My name is Akshaj Kant and I will be talking about the introduction to cache memory. The term cache refers to a thing that is hidden or stored somewhere or the place where it is hidden. The cache is a smaller and faster memory that stores copies of the data from frequently used memory locations. Cache memory is a temporary memory which is also called as CPU cache memory. Cache memory in our computer is mostly built on the top of the processor or the CPU chip itself for faster access of the data. There are various independent caches in a CPU which store instructions and data. Characteristics of cache memory. Cache memory is used to reduce the average time to access data from the main memory. Cache memory is an extremely fast memory type that acts as a buffer between the RAM and the CPU. Cache memory also holds frequently requested data and instructions so that they are immediately available to the CPU when needed. The cache memory is costlier than main memory or disk memory, but it is more economical than CPU registers. Cache memory is also used to speed up and synchronize with a high-speed CPU. Then we have the cache memory diagram. So whenever a processor needs a piece of data, it first searches for that data in the cache. If the data is available in the cache, the processor directly accesses the data from there. If the data is not available in the cache, the processor uses the data from its source. And here the source is the main memory. It also copies the data into the cache, assuming the processor will soon require the data. Thus, we can conclude that the cache holds frequently used data. So whenever the processor requires the data, then the next time it can access from the cache at a much faster rate. Hence, we can say that the cache acts as a buffer between the main memory and the processor.
So, my name is Mayank Ahuja and I am roll number 20 of Division A. The topics which I will be explaining are cache performance, hit ratio, and cache mapping. Starting with cache performance. When the processor needs to read or write a location in the main memory, it first checks for a corresponding entry in the cache. If the processor finds that the memory location is in the cache, then a cache hit has occurred and data is read from the cache. But if the processor does not find the memory location in the cache, then a cache miss has occurred. For a cache miss, the cache allocates a new entry and copies in a data from the main memory. Then the request is fulfilled from the contents of the cache. Hit ratio. The performance of cache memory is frequently measured in terms of a quantity called hit ratio. The formula for hit ratio can be given as hit ratio equals to hit divided by hit plus miss equals to number of hits divided by total accesses, while the formula for miss ratio equals to number of misses divided by hit plus miss equals to number of miss divided by total accesses, which is also equal to 1 minus hit ratio. The cache performance can be improved using higher cache block size and higher associativity. Reduce miss rate, reduce penalty, and reduce the time to hit in the cache. Cache mapping. There are three different types of mapping used for the purpose of cache memory, which is as follows. The first is direct mapping, second, associative mapping, and third, set associative mapping.
My name is Durva Ajaonkar and my roll number is 21. The topics that I am going to explain are direct mapping and associative mapping. Direct mapping. In direct mapping, each memory block is assigned to a specific line in the cache. An address space is split into two parts, index field and a tag field. Direct mapping, cache line number, I equal to j modulo m, wherein I stands for cache line number, j stands for main memory block number, m number of lines in the cache. Then associative mapping. In this type of mapping, associative memory is used to store the content and addresses of the memory word. Any block can go into any line of the cache. In associative mapping, the index bits are 0. It is considered to be the fastest and most flexible mapping form.
So, my name is Akash Chimkar, roll number 22 of Division A. So, further in the discussion of cache mapping, now we will learn about set associative mapping. So, basically, it is an enhanced form of direct mapping. Addresses the problem of possible trashing in the direct mapping method. Instead of having exactly one line that a block can map to in the cache, it will group a few lines together, creating a set. Then a block in the memory can map to any one of the lines of specific set. Here we can see the block diagram of set associative mapping, where it consists of main memory, cache control logic, CPU, and some block frames. So, relationships in the set associative mapping. This two formula gives us the relationships in the set associative mapping. M is equal to V into K, I is equal to J mod V, where M is equal to number of lines in the cache, K is equal to number of lines in each set, I is equal to cache change set number, J is equal to main memory block number, and V is equal to number of sets.
So my name is Ahmad Ali Sayyed. I am roll number 19, Division A. The topics that I'll be explaining is application of cache memory, advantages of cache memory, and disadvantages of cache memory. In applications of cache memory, primary cache. A primary cache is always located on the processor chip. This cache is small and its access time is comparable to that of processor's registers. Secondary cache. Secondary cache is placed between the primary cache and the rest of the memory. It is referred to as a level 2 cache. Often the level 2 cache is also housed on the processor chip. Next we have spatial locality of reference. Spatial locality of reference says that there is a chance that element will be present in close proximity to reference point and next time if again search them more close proximity to the point of reference. Discussing about the advantages of cache memory, it is faster in comparison to main memory and second memory. Programs stored by cache memory can be executed in less time. The data access time of cache memory is less than that of the main memory. It stores data and instructions that are regularly used by the CPU. Therefore, it increases the performance of the CPU. The disadvantages of cache memory. It is costlier than primary memory and secondary memory. The data is stored on a temporary basis in cache memory. And whenever the system is turned off, the data and instructions stored in the cache memory gets destroyed. The high cost of cache memory increases the price of the computer system.
Thank you so much for watching our video. Thank you.